calculated by separating it into components, we get a positive moment. In order to create a positive moment about B, doesn't the force have to be above B? Because if the force is above B, my fingers go in the direction of force, palm goes towards the point, I get a positive moment. But how about here? I put my fingers in the direction of force, palm goes towards B, I get a negative moment. I calculated that the moment about B was a positive value. In order for it to be a positive value, it has to be at this position 1. Okay? Questions? Okay, so what did we do so far? We were able to calculate the magnitude of the moment, and then we were able to calculate the direction, checking using right-hand rule. So we calculated the magnitude of the moment using the perpendicular distance, and then we used our right-hand rule to find the direction. In a case where there was a problem that we didn't know the perpendicular distance, we broke it up into its components and solved for it. And then we also went on and we were able to calculate what the perpendicular distance is. Okay. Let's do another problem. Now we're on the next page, which I guess is the back. And I copied it for you, I think it's on the back. So do you see where, what do I want to find out? I want to find out the moment about point O. Does everybody see where point O is? And let me put 2 little marks in here that you should add. So this right here, these 2 forces, F2 and F1, are perpendicular to that line. So what we need to do is we need to find the moment about point O due to F1. We want to find the moment about point O due to F2. And we want to find the moment about point O due to F3. Because would you agree that any forces on here are going to create a moment, can create a moment about point O, right? Okay, so calculate those. You can work with the person next to you.
thousand? For F3, could you just do cosine 30 times 20 times the 100? I think I was saying 60. What's the angle between the y and the line in the middle? Should have been that thing? No, I think, I mean, I kind of used the edge of the point was back of this line. And we're trying to find it, the y bar. Or I guess the x, there's probably some x too. No, because it would, no. Shoot.
Eugene, pass that to Sam.
Oh, gotcha.
Yeah. So I got something like yeah.
Okay, so, Lonnie, let's do the first one. So, we're trying to find the moment about point O, which is the dot in red, due to F1. So it's the absolute value of the force times the perpendicular distance. Did you break it into components or no?
No.
I did, but I started for some reason with F2.
Okay, so in the end, do you think we should break F1 into components, or are we given the perpendicular distance?
We're given.
We're given. So in this problem, we weren't given the perpendicular distance, so I wound up breaking it up into components, but here I am. So F1 is 30, and the perpendicular distance is 75, right? Okay, and is it positive or negative? So fingers go in the direction of the force, palm goes towards O, a negative value. Thanks. You guys can just tell me. 2250. And what are the units? In foot?
Pound.
Foot, thank you. Foot, pound. And it's negative. Okay, Rachel, how about F2? Are we given the perpendicular distance?
Yes.
Yeah, so it's 40 times 25.
I did it all in one step, so I don't.
Good. Positive or negative? Negative. Okay, Sarah, how about F3? Do we have a perpendicular distance?
You can get the perpendicular distance by drawing a triangle.
Yeah. Right, because here's F3. F3 is like this. This is the perpendicular distance right here, and they give you 50 and they give you 30, right?
So what if you just do the sine of 30? Would that work?
Yeah, that's what it's coming out to be. So the force is 20, and the perpendicular distance is,
Cosine 30, you do cosine 30 equals x over 100, it ends up turning out to be 6.
okay, well, let's just do it. 100 times the cosine of 30. So what did you say? You said sine. Did you use sine of 60? Chelsea, you said sine.
I had,
So we're trying to find this is, right, we're trying to find this, everybody look up here, we're trying to find this distance. Here's 30, so it's gotta be the cosine of 30 times 100. And does it create a positive or a negative moment? Negative. And what does this come out to be? 1732 foot-pound. So in this particular case, there are 3 forces acting on this problem, and each one creates a moment about 0.0, right? And now, do we need to add them up? Yeah, we need to add them up, because in the end, the moment about 0.0 is a sum total of this. So what does that turn out to be? 4982 foot-pound. Good, Lucas? Yeah, thank you, negative. Important. It doesn't make sense, again, I could use my finger at the point that I'm trying to find the moment about, and all the forces are going up. So they're all gonna create a negative moment about 0.0. Now, if you think back to math or physics or even last class, I talked about there being 2 different ways to find a moment, right? One is using the right-hand rule, and the other is using vectors, vectorially. So let's go back and do number 2, vectorially. So let's get the sign convention correct.
Wait, so we didn't have to we didn't have to add a positive to that last one? Oh, we didn't have to use the component in the x direction?
Tell me again?
So for F3, we didn't have to add that because it would be a positive moment about O?
Well, we have the force right here, right? F3 is right here. So it's going in this direction. And I have the perpendicular distance, so I can take the total, 20 pounds, and multiply it by the total distance, and I'm done,
Yeah, there's no x.
right? There's no x, that's fine. But actually, that leads into a good question when you asked about x or y. When you do a 2D problem, you always say this is the x direct positive x, and this is the positive y, right? X, y. Does everybody agree with me? X, Y. So what is it spinning about? It's spinning about the z-axis, right? If we have a negative, a positive spin, it's spinning about the z-axis that's coming out at us. Here is the z-axis coming out at us. Here's the z-axis coming out at us. So in a way, if we wanted, if we wanted to represent it as a vector, we could have done this, right? But we know in all these cases we're dealing with, in any 2-dimensional problem, if the forces and the distances are in the xy plane, it's got to be spinning about the z. If all the forces and the distances are in the xy plane, the spin is about the z-axis. That's a good transition to, let's do number 2. So first, let's get the notation correct. So you said in order to find the moment, it's vectorially, right? Vectorially. And how do I represent it? The moment is equal to, as vectors, r cross f, right? R cross F. So let's take a look at our number 2. Our force is coming off point C, right? So So I'm gonna put a subscript of C for the force. Everybody see? The force is coming off C. I'm looking at number 2. I'm looking at number 2. And I'm trying to find the moment about point A, right? So what are my subscripts for R? It always has a beginning and an ending. R always comes from the point I'm finding the moment about to the tail of the force. Can everybody see that it says AC? So look at this. If I'm trying to find the moment about point A, this subscript's going to be the same. And if I'm trying to find the moment due to the force at C, this subscript's going to be the same. So the moment about A is equal to R going from A to C cross C, the force C. But this is all in vectors, right? And if you want, we could come back and put all these little guys on here. That's something I get sloppy on. I never usually put those. But now we need to find out what they are, right? So let's go on this side. I think we only need one. Is that okay if we have one now right here? The moment about point A is equal to R cross F, and F is at C, so R goes from A to C. So let's write down what RAC is. So in vector form, I think Sarah, we're up to you. So if I wanted to draw my RAC on here, my RAC goes from here to here, right? RAC. So what is it, how would I write it in vector form?
Depending on where you put your axis.
Right, so let's use the standard axis. So this is my X, and this is my Y. So RAC is equal to?
-5I.
It's
Well, I
going
mean-
from A
I mean,
to
if
C.
your axis, if the origin is at C,
It doesn't matter whether the origin is here or here. We still know that the direction, we want to know what the distance is from A to C. And then we need to know the direction it's going in. Whether the origin is here or here, we're going from point A to C.
okay, so 5I is 7J.
5I plus 7J. Do we need any units?
Then,
Inches. Everybody agree? Going from A to C, I'm going 5 in the J, 5 in the X and 7 in the J. And then what is my vector for F? Claire?
Vector for F, like the distance?
No, we need to have magnitude, it's a vector, right? So we need to have magnitude and direction. 150.
Times, -5?
Right, and negative, so negative 150, and what's the direction, I, J, K?
I? There's no 5 in there, just negative 1.
No 5, because 5 happens to do with, has to do with the distance, right? So, my R vector, what's my R vector? It's a distance vector. R is distance, right? Everybody knows that R is distance. So going from A to C, it has a 5 in the X and 7 in the Y. The force vector only represents the force. The force is 150 pounds, but I have to show its direction, and its direction is -I. So do you remember how to set up the cross product? using a determinant, so we have the first row. What is the first top row? Chris, what's the top row?
5, 7, 5i, 7k.
Okay, that's the second row, so let's write it in.
J.
5, 7, and
0.
0. So the second row represents the R vector. The third row represents, Chelsea,
The force,
the force vector. So the force would be what?
would just be negative 150.
Right.
0.
0 and 0. And what does the top row represent? Right? Nicholas? IJK. IJK.
Why do we have the top row?
Say it again?
Why do we have the top row?
Why do we have the top row?
Yeah.
Because in the end, we're crossing two vectors, and a cross product gives us a vector, right?
Mm-hmm.
In fact, what does the cross product give us? What kind of vector? Nick, do you remember?
Perpendicular. Horizontal.
It's a vector that's perpendicular to both the two that you're crossing. So this moment is a vector that's perpendicular to these two vectors. So we have to have it in vector form in the end. So we put the I, J, and K. Now there's a number of ways to do this, and I kind of know the different varieties of what you guys do. So let's, what I tend to do, well, one is use the calculator, right? Plug it into the calculator and you're done. Okay, if you do it by hand, the way I do it is I know I make less mistakes. I rewrite these two rows, I and J, 5, negative 150, 7, and 0. So I rewrite the two columns here, and then I go this multiplied plus this multiplied plus this multiplied. So this is 0, 0, 0. And then I subtract coming back. This is a 0, this is a 0, and this is a 7 times negative 150 times k, but I came backwards, so I have to do a negative. So what does that come out to be? What's 150 times 7?
1050.
1050 k, and it turns out to be a positive, and the units were foot pound, inch pound, inch pound. What I think more of you do is you look at this and you say, look up here, you isolate the I and say this minus this, and then you say plus the J, this minus this, and then you say the K and you say this minus this. Okay, so how many of you have done it this way where you draw out those last two columns?
3 times.
Okay, and then how many of you do it where you're basically taking your I, J, and K, you have to remember to subtract the J, right? And then you have a 2 by 2 matrix. So let's see, I would
I
be
get that way, but in my head.
7, 0, 0. I'm just going to write it out for everyone. And then J is 5, negative 150, 0, 0. And then the K is 5, 7, negative 150, 0. Now, keep in mind that you told me that in physics, problems that you were doing were 2D problems. Is that right? Most of the statics problems you did were 2D, not 3D. So it's going to get more complicated. So learn how to do it on a calculator, and then you don't have to do it in your head. This one's easy to do in your head, I think, because there's 3 zeros in there, so many zeros, it's all going to be canceled, right? So it's I times this minus J, remember the minus, this times this plus K, this times this, and here we get the same answer, 1050K inch pound. So did we get the same answer for MA that we got
Yeah.
when we did it before?
Yes.
Good. Okay, so how about now MB? Chelsea, are we up to you, I think?
Yeah.
Okay, so M is equal to R cross F. What is the subscript for F?
For F, it would be B.
Where's
Or
F
C,
coming from?
sorry.
C. And then R goes from,
B.
right, to
C.
Right, so here is my RBC. So RBC equals, Kyle, what's RBC?
Negative 10I plus 7J.
Great. Units, inches. FC is equal to, Kyle, keep going. What's the force? Yeah, it's okay, right here.
Oh, yeah.
Negative 150, IJ or K?
Negative 150I.
Right. And it's pounds. So then let's write it up over here. Let's just do it. So the moment about point B is equal to RBC cross FC, which equals IJK. Nicholas, you wanna tell me what, oh, it went backwards, didn't I? Nicholas, could you tell me what R is? It's over there.
Negative 10, 7, 0.
Okay, and then F was negative 150?
Yeah.
So in the end, again, we have a lot of zeros, right? So where's this guy? It's gonna be K, we know it's gonna be K. So it's K times this zero, a minus 7 times negative 150. Right, so that's 1050 again.
How do you get minus 7?
Oh, you gotta put a neg,
Not
oh,
the
no, you don't.
Okay.
Yeah, see, I always do it that way, that I just messed up. You don't put a negative in. Thank you.
So you do.
Put a negative on the outside.
You do, yeah. You do.
Oh, I do,
Yeah.
yeah,
Yeah, you do.
right, because I'm going this way, yeah. Okay. Okay, we do a 3D one? Let's do a 3D one.
So Joanne, I noticed that
Yeah,
in
go
the
ahead.
homework they talk about the moments about the axes, where these are talking about moments about points.
We haven't gotten, well, in the end, you could say that because, oh, I left something out here, didn't I?
was
What did I
hoping you
leave
could-
out?
I was just hoping you could do an example of one.
I forgot to put in the X. So what we're doing is we're finding in the end the moment that's spinned around the K, which is the Z-axis that's coming out from that point. So you can think of it as finding moments about a point, but we're solving for the moments about that axis. We're gonna do some problems where we're finding a moment about a line that has nothing to do with X, Y, or Z axis, like we talked about bike frames. We might wanna know what the moment is about some bike frame that frame is not pointing in the X, Y, or Z axis. Does that make sense? So we're finding the moment about Z, but about that point.
Okay.
Let's take a look at this problem. So this is in the packet, I don't know who has it or not. So, I want to find the moment. Lucas, back to you. I want to find the moment about point C, so I'm going to say R cross F, and F is going from what point to what point here? A to B. So what does R go from then? From C to?
F? B?
To A. So our R vector goes from the point we're finding the moment about to the tail of the force. Tail of force.
Always.
I do it that way standard, but you'll see that you can do it to B if you want it. But we'll talk about that another time. So RCA, Jabin. So R goes from point C to A, so what's the value that it's going in the X? So again, you gotta look at this in 3D, right? Pull out your parallel rule if you need help.
Negative 100
Negative 100I,
plus 250
Right.
J
250J,
plus 120 K or 1
plus,
200 K.
take a look at the Z axis.
I was looking at the yeah, it's 180.
180, okay. And it's millimeters. So everybody look up here, going from C to A, I went 100 in the X, and it's going in the negative X direction. Going from C to A, I'm looking at the left side of my plane, that's where C is, and it's 250 over, and it's going in the positive Y direction. And then C lies on the bottom of this box, and A is on the top, so it's going up 180. Okay, now let's do FAB. And this is where we're dealing with components, right? It's 735 newtons. And let's see, so going from A to B, Aaron, we're up to you. A to B, how much am I going in my X?
200,
200, positive or negative?
positive.
Right, how about Y,
Positive 250
right?
and negative 180 in the Z.
And negative 180K. And then it all goes over 200 squared plus 250 squared plus 180 squared. And this is in newtons. 735. Somebody might get the numbers before I get mine. I have 0.5450 plus 0.6810J minus 0.4901K.
You can't see.
Oh, okay. So it equals 400.0I plus 500.0J minus 360.0K. Okay, so we're trying to find the moment about point C, and it was R cross F, and F went from A to B, and R then went from C to A. The first row is I, J, K. The second row is the R vector. I have to pull this up. Negative 100 plus 250 plus 180, and this is 400, 500, negative 360. And the moment about point C turns out to be 180I plus 36J minus 150K. And the units I want up converting Newton meter.
So, Joanne,
Yeah,
do you want us to do the checks when we're coming up with the vector space?
well, you should do it, right? Unless I ask you. If I don't ask you to do checks, you don't have to, but if you make a mistake, it's worth it to do it.
The homework said that we can check it just by checking our right-hand rule and vectorial, right? So we don't have to do the checks, right?
Okay. Well, in this second homework, in this last homework that I just assigned, the moment homework, the way you're checking it is because you're doing it by right-hand rule and you're doing it vectorially, and that's your check.
Right, right.
Correct.
Okay.
Rachel?
Do you have to put like the IJK in the
You cannot. Your calculator, from what I remember from past students, you can't put I, J, and K in there. You have to put it as independent 2x2 matrices. So I think this is what you have to do. I think you have to do these guys. But when we get to something else, then we'll have a complete determinant. But I don't think you can put I, J, K in there. Yes, that's exactly where we're going. Is everybody ready? Okay, so let's look at the I component of that moment. Is it positive or negative? The moment about the x-axis is negative. Okay, so what I want you to do is see where the x-axis is here? Stick your thumb going in the positive x-axis. When you do that, if your thumb is going in the same direction as the positive x-axis, it's a positive moment. So did we get a positive or a negative moment? Negative, so it's spinning the other way. Put your finger going in the other direction. So let's draw this. Okay, watch this. Is that the correct spin? I'm drawing it in 3D. Is that the correct spin to get a negative?
Yes.
Yes. Why did I not show this? Why did I not draw this? This red part here? Because it's behind the axis line. Okay, what about Y? Put your thumb in the positive Y direction. Did we get a positive Y? Yes, so how is it spinning? Is it spinning towards us or away from us? Towards us. Does that show a good spin? Does that show that? Does that look clear to you guys? Okay, let's do the Z. Put my thumb in the positive Z direction. If I get a positive Z, did I get a positive Z? No, so which way should my thumb go? Down. How's that? Does it look okay? So we have to be comfortable drawing these spins in 3D. So this force is creating the x-axis to spin negative. Does that make sense? If I held this axis, with this force going down on this side, wouldn't it spin like that? Right? I'll do it again. Here's my x-axis. This force is going down on this side. If this force is going down on this side, wouldn't it cause the axis to spin like this towards it? Okay, let's try the y. Here's my y-axis. The force is going down in front of it. It's causing it to spin this way. Doesn't this make sense? I'm in a way doing a visual check. How about the z-axis? Well, can we see this in 3D? Yeah. This force is going down to the right of it. So does it make sense that it's spinning this way? Yes, because it's being pulled out this way. And this is what you're going to get more comfortable with. You don't have to see it in 3D and understand how these spins are going yet.
Yeah, yeah.
So for two-dimensional problems, are you comfortable doing right-hand rule? 2D problems, right-hand rule. For 2D problems, we did R cross F, we did it vectorially. Comfortable with that? Okay, so your homework is all 2D problems, doing right-hand rule and vectorially. And they're gonna check each other, because you should get the same answers. Then, we just did a 3D problem using vectors. The most fun is doing a 3D problem using right-hand rule. And we're gonna be doing that next. Okay, so let's look at the syllabus for a moment. So looking at the whole